Fantastic. All right, well, welcome to today's Training Tuesday, everyone. As you can tell, Chuck and I are here. We're working from home. We have some weird things going on in the office. So it's a little different as far as technical. I want to welcome you to this week's Training Tuesday. I am Heidi Reese here at Dayton Superior, the Training Programs Manager. Just a couple of items before we get going with today's training. Same old, same old. I want to let everyone know that you've been muted. I still want you to ask questions throughout using the chat functionality or the Q&A functionality within Zoom. At the end of the presentation, we'll definitely have a mini question and answer session. If there's not time, we can still get your questions and get them back to you with answers. At the end, I will email them to you. Hopefully we will though. As a reminder, all of these webinars are recorded and placed on our Dayton Superior YouTube channels, as well as our DaytonSuperior.com. They're all organized by the various products so that you can get to what you need, and I hope that you are utilizing them. They're very quick, 30-minute sessions, and they're great to have at your disposal to remember what you want to learn, or just to refresh your memory on things. So another reminder, this presentation is intended for training purposes only. Anything that is discussed, and if you need technical specifications around those products, please visit us at DaytonSuperior.com. There's technical data sheets, safety data sheets, application guides, you name it out there. So please refer to DaytonSuperior.com for that. So let's go over, once again, Dayton Superior. We are the leading provider of engineered solutions for the concrete construction industry. We handle accessories, chemicals, forming, but we also do engineering for you with those, as well as training. So these are quick training Tuesdays, like I said. They're very insightful, but again, they're quick. They're just topics to get you going. If you need more customized solutions for your job, your product, your place of business, please contact us at training@DaytonSuperior.com, and that goes straight to Chuck and myself, and we'll get back to you. So Dayton Superior is, like I said, specializes in all of that, but we have chemical solutions that is specifically formulated. They meet the design specifications both in new construction and your repair and retrofit needs. We also have Simon's Forming and Shoring, very adaptable with each other. It's strong and it saves on the labor costs out there. If you haven't dealt with that in the past and you need forming, please contact your sales representative for that. And just to let you know, I did talk about engineering. The engineering and sales team, as well as our technical sales group, is fantastic. So please get out there and utilize them for what you need for whether it be precast or slab works, bridge deck, as we're discussing today. We'll talk a little bit about that with resources at the end, as well as customized forming solutions for you. So as you probably heard, you know that Chuck is going to be doing today's bridge deck estimations and installation. And he's going to be going over the overview of the products themselves, and how to estimate the accessories that you need for this, as well as how to install your bridge deck, and then go over the resources that I mentioned. So if you guys don't know Chuck, well, you should get to know him. He definitely is the biggest guy in the industry as far as the knowledge. He has been with the construction industry for over 49 years, so he knows his stuff. 20 of those was as a dealer for accessories, forming, and chemicals. 29 is with Dayton Superior. We're very happy to have him because he is that one-stop shop of education. He knows it all. He really, really does. If you didn't see him at World of Concrete last week and talk to him, I asked you guys to stump him. I hope someone did that and gets back to me. He is a business and civil engineering degree. It contributes to his role with that subject matter expert. And he's going to share his knowledge with us today on bridge deck estimations and installation. So Chuck, take it away.
All right, well, thank you, Heidi. So, like Heidi excluded, we are going to talk today about the overview of the products. There's going to be a lot of slides going through here, so if you do have a question or if we lose you someplace, either ask a question or reach out to talk to us afterwards. We'll be more than happy to actually give you an independent training on all the products here that we can do either by Zoom or we can do it in person. So with that being said, let's get into this. So the bridge deck product here, we're going to be talking a little bit about cast in place, precast, steel, wood, concrete, supported on concrete or steel girders. We're going to talk about the sheathing, the joists, the ledgers. Those items typically aren't seen as often as they used to be because of now most of the decks are actually going with either a composite fill or either concrete plank or an SIP decking. SIP means stay in place, corrugated metal decking. But we'll talk a little bit about overhang brackets and the accessories that are needed. All the formwork that goes with it, walkways, paving machine loads, because that is a huge product item, especially when you're talking about bridge deck. Additional accessories, basically, that are going to be required and used. We'll talk a little bit about Simon systems that are relevant within the system, and obviously chemicals, curing to control and finishing the concrete to protect from elements. And then obviously we're going to talk about our engineering services. So let's start with the overhang brackets. Overhang brackets, the C49 standard bracket, probably the most copied bracket in the marketplace. This bracket been around for about 40 years now. It is used basically continually across the country. You can adjust this bracket from 14 inches to 30 inches, or if you go with the deep bracket, you can go up to 70 inches with it. We also have, in the S bracket, is the field modification of that C49, where you're actually going to take it from 30 inches, which is the standard length, to about 14 inches. And that can be done with basically removable one pipe. We also have our junior brackets, which actually typically are used in those tough to fit locations where you don't have 4.5 feet in between the old structure and the new structure. Or if you're doing work downtown, you may not have 4 feet between a building and the edge of the bridge. So the junior bracket comes into place. It's a very select product used, to be honest with you, I think in my almost 50 years of doing this, I probably used it close to a dozen times. So it's not something you're going to use every day. Just know that it's out there and available. We have our C49C, which is our extended capacity bracket. This is the same bracket as the C49, only on steroids. We have basically beefed everything up on it. This bracket typically requires a little bit heavier hangers. You have to actually have additional supports for the C49. And this is one of the newer brackets that we've come out with. Hasn't really, because of the extended capacity, there isn't a longer version of it. Basically is just that 54 inches. And then we have our C49W, which is a West Coast style bracket. And for those of you that in the seismic design out West Coast with the AASHTO type cast in place girders and tub girders that they use in the West Coast, this bracket makes forming up the overhangs much easier. Well, supporting all those brackets actually comes from the hanger. The hanger is actually one of the key components, is what I would consider the second most important part, because it's the one that actually holds the bracket in place for the overhang. And the brackets can come in a multitude of different styles and configurations. Here we just have about 6 or 7 different configurations. We can actually, all the hangers are typically made to order. We do not stock any hangers on the shelf. If we have any on the shelf, it would be a C24 style hanger, as those are the most common half hangers. But whether or not it's a type 1, type 2, etc., would be based on your location. And with those hangers, steel beam requirements, we've got hangers basically that will wrap around steel beams, straddle over the top of them. We've also got precast hangers that will actually cast in place in the concrete, and you can get those with a 45 or 90 degree end clip. And the end clip is what decides what the hanger is going to be used for. Typically, a 45 degree clip is used for an overhang bracket, connecting to an overhang bracket. A 90 degree is typically attaching to a wood forming member. And we can do precast hangers, and once again, they are MTO. The standard is a 6x4x2, but we can do those hangers up to, we've done them up to 48 inches by 6x2, just so you get back in that concrete platform of the deck of the bridge beam, and where you have enough meat to actually hold that anchoring force. We can put steel plates on the end underneath the clips to actually spread the load design out on the edge of the girder, so you don't have to worry about chipping the concrete girder. And once again, these are all made to order. So typically what you've got is 1/2 inch by 24 adjustable coil bolts that are going to be used. Those are a preference that I have in the marketplace. It is not the only item that can be used. This is what holds the overhang bracket to the hanger. I like it because it has the adjustable nut on it, but what it also gives you is it has that one nut at the very bottom that is welded. And when you're done to go get ready to strip the bracket, that enables you to loosen that bracket up with a wrench, so you don't have to damage any of the threads, thus making this component piece reusable. 24 inch is preferential. I've seen guys come in with 18 inches. They'll go try 20 inches. I like the 24 because that kind of fits whether or not you have to have a high haunch or low haunch on the overhang, whether the bracket is sitting flush or if it's sitting down just a little. The bracket, that adjustable coil rod will actually make that bracket easier to adjust. You can also use standard B12 coil rod with a nut in lieu of that, but to strip it, you're going to have to muck up the threads on the coil rod to actually get it loose. You'll have to hook onto it with a pair of vice grips or a pipe wrench to actually break that loose. We have our wall plate adapters that can be used to attach the overhang brackets if you need them to attach to a wall, a concrete beam, a box beam type construction. This gives you a little bit of adjustment, about 1.5 inch adjustment up or down for the overhang bracket. And you can use a drop-in or a cast-in place insert in place of it. It also enables the overhang bracket to be used as a scaffold bracket. And we've always got our C52 guardrail receptacles for the guardrail posts, and we can also add a extender, C54 extender. And the C54 extender enables you to get 20 inches of additional walkway space. So you can actually sheet that out with plywood and 2x4s to gain an extra 20 inches of walkway for the people to walk along the deck.
So then I could come out and hang with you and walk around, Chuck?
Yeah, you can walk around the back, just have to make sure you duck underneath the finishing machine.
Gotcha.
So then we have bar supports. Bar supports are the next important item that we have in the deck. Typically, whether you're forming on concrete plank, wood decking, SIP decking, we can supply the slab bolster for that need. Whether it be galvanized, epoxy coated, stainless steel, all plastic, etc. We have a complete array of slab bolster, including the plain metal version, which we don't see a whole lot of anymore, but most of the jobs are going typically epoxy coated or galvanized. We also have the upper material. Once you put the lower material on to touch the formwork that's underneath, because that'll typically have a plastic barrier on the feet, we go to the second mat, which needs to be supported by slab bolster upper. And slab bolster upper is a critical component because with SIP decking, you're going to use slab bolster upper on your lower deck and on your upper mat of rebar. So let's talk about how do we estimate the deck? Well, typical bridge deck. You're going to look at a set of plans here. This is a typical Ohio bridge. This is a plan view of the deck or a detail of the beam. You got basically the framing plan from end to end is located on this one. You'll also see that we have here our steel. This is a steel beam structure, and the steel beam is detailed out here. Now, a lot of times when you use steel beams, the steel beams typically will come in either in a couple of different forms or fashions. It will have a build-up girder or will be a standard extruded beam. If you have a build-up girder, there's a good chance you're going to have multiple hanger widths on it because the beam flange on the top side of the girder is going to change. And they will typically change in both the tension and compression zones of the bridge. And what we're concerned with is what's going to happen up on top. Typically in a tension zone, because the bridge being the way the camber is of the bridge, it's basically an arc going up over the bridge. And when the concrete gets on it, that beam is going to settle out. What happens is it takes the concrete beam, actually has to have those tension and compression zones to basically stretch and contract into areas so that when the beam flattens out, we don't do any damage to the girder itself. So here, you also will have a section view. The section view is now going to give you all the other details that you need for your how to calculate the overhang bracket. There's a bunch of information on this page. Realistically, these are probably the two most important pages on the plans that you will need for a bridge takeoff. Typically, this is going to give you your overhang, your rebar size, your rebar coverage on the top of from the top of the concrete deck to the rebar, and also from the bottom of the concrete deck to the bottom of the bottom mat of rebar. You will have to calculate the space in between. I would recommend going to the how to calculate slab bolster presentation that we did a while ago here for a Training Tuesday. That will actually help guide how you actually run that figure. But you'll also get all the rebar sizes, any lap lengths, anything, any special conditions within the deck will be listed on these pages. So let's build a quick estimate here. So you're going to have, remember, when you get your plans, yeah, I had a guy send me about 4,000 plans, that's 4,000 pages the other day. Of the 4,000 pages, I think I needed 3 pages to actually calculate the deck to do the whole deck calculation form. So you don't really need to have the whole set of plans. You're basically just looking for individual, primarily that section view and the plan view of this product line. So basically what you're looking for is the overall length, the girder details of spacing, the deck thickness. Obviously the concrete thickness of the deck is going to play an important part on the weight that's put on the overhang bracket and the hangers. The width of the bridge comes into play because the finishing machine. The finishing machine is not your friend. The weight of the finishing machine is probably 85 to 90% of the weight that the overhang bracket will have to support. So with today's wider bridges, because we're having to build bridges wider and wider because we keep adding lanes to highways, you end up having a heavier finishing machine. When the finishing machine starts to get up around 25 to 2,800 pounds per wheel, well, that only leaves you 800 or 900 pounds per lineal foot of concrete that you can add. So you're talking, you've lost a lot of capacity of the bracket because you're having to take into consideration the weight of that finishing machine. So with that being known, and the contractor will have to give you that information. That is something that cannot come from Dayton Superior or any of the dealers out there that are looking at it. This is something that the contractor will have to give because we don't know what kind of options they have on their finishing machine, etc. So you're also going to get a top bar clearance, a transverse bar, the longitudinal rebar, and what size rebar it is, because that's going to help determine the rebar size of the rebar chairs. You're going to get your bottom rebar size and coverage and clearance from the bottom. And you're going to have the information for center-to-center spans if it is a removable wood deck. That's going to tell you from center to center is what the spacing is on the beams. You're going to be able to, from that figure, you can calculate the clear span, which will tell you how much space you have from the edge of girder to edge of girder. So here we have a typical deck as we showed earlier. Here's the framing plan. As you can see the bottom here, you can see the girder running down through here with the build-up areas here, and the beam flange will be denoted here on this drawing if there is a built-up plate there. So it'll tell you how long it is and typically the location of it. So here we have the overall length. You have the girder details. You have the girder spacing. You have the deck thickness. You have the deck thickness over the girder, because a lot of times that will change based off of what the haunch is required, because the haunch is an area that is actually a figure that how far up they're going to raise the slab, the concrete deck slab, typically so they don't have to pour the full depth from the top of the girder to the bottom, basically from the top of the girder to the top of the deck. That distance is typically whatever the deck thickness is minus whatever that distance is. And what happens is it works out, a lot of times bridge decks have a 2-inch haunch on it. That enables them to maintain a consistent 8-inch or 10-inch deck thickness across from end to end of bridge. Sometimes engineers get a little carried away, and what you'll end up having is you may end up having a 10 or 12-inch deck on one end of the bridge deck, and you may not have but 8 inches over the dead center part of the bridge deck. So what you're seeing is a thicker bridge deck going on. This does two things. One, it adds cost to the contractor, and we try to eliminate a lot of that wasted cost with them. And two, it actually ends up causing a lot of forming issues, because added weight means you may have to go with heavier forming hardware. From there, we have our bridge width here from out to out. You see where the out to out is located. It's the top figure there because you want to go all the way out to the edge of the bridge because that's where the finishing machine will be set up for. And that's typically where the finishing machine will run off of, is when they run it off the overhang brackets. 90% of the projects that we see today are all the overhang bracket is actually supporting the finishing machine. For top bar clearance, we get that on the same page here. We get our rebar size, whether it be longitudinal rebar or transverse rebar. We'll also get our bottom rebar size from the same pages. And we also get the bottom bar clearance, which is typically a figure that we see usually right in this area here. You'll see where they actually have, so you may see it shown 2 or 3 locations on the bottom half of the, underneath the deck, that they'll say concrete coverage is. So from a typical deck section, you can determine the center of center from the girders. Typically, the reason you need that is if you are doing removable wood form, the center to center is going to determine what size lumber you have to use for your forming hardware and what size hanger you have to use to actually support that load. And typically what you want to do is you want to match up your interiors to your exterior so that everything lines up across. Because if you can't do that, then it gets a little bit convoluted. I mean, it gets real crazy in trying to calculate the location of all these hangers, where they're going to be. So from the framing pan, we determine this the top plate of the girders. Typically here has got a 14-inch girder on top and a 22-inch. Now thicknesses will also be listed there, so if we have to have any hangers that wrap around, those thicknesses will be associated with either the 14-inch or the 22-inch also. So typically you're going to always pick, to run your calculations, you always pick the smallest flange width, primarily because that's the worst case scenario. So typically here we got 8 foot 6 inches. We have a 14-inch beam flange, so we deducted 9 foot 8 center to center minus the 1 foot 2. Comes out with a 102-inch clear span for this example. So typically here we got, let's say we have an 8 foot here. In this example, we got 18-inch beam flange, 8 foot clear span. You determine that the clear span is actually 6 foot 6 inches. That's the distance that we have to design the lumber around for. So we're only designing in and around that 6 foot 6 inches. And that'll relate out to, you just pop the numbers into the formula where you're taking the center to center minus a beam flange thickness, the total thickness, because it'll be half from one side and half from the other side. So here it gives you 102% for this project here. Oh, man. So with that being said, you're going to know what size lumber you have to have. We have charts in our bridge deck handbook, which will tell you an 8 foot spacing. Typically, if you use a 6,000 pound hanger, it's going to be about 4 foot maximum. Typically, 4 foot max is the maximum that you want to go on the interiors, primarily because of bending stresses within today's lumber. So let's start out forming here. We've got our lumbers put in place here, all the dimensional lumber put in, formwork, joists, ledgers, plywood. So it says we have to have 1.5 inches of coverage on the bottom. So typically you are going to put, from each beam, you're going to put a row of bar supports that's going to run parallel to the girder. Now that length of the girder typically it may be a foot off of it, it may be, 6 inches from it. Depends on the width of the girder. You're going to then take that and base off of this, you have a 6 foot 6 inch clear span. I may put one, and because it's only a 14-inch girder, I may put one row right on the edge of the plywood and one end on the other edge of the plywood and possibly one in the center. More than likely, most contractors, what they would get away with is just 2 rows on this bridge. That is something that the conversation has to take place with the contractor. So typically, you're going to take the number of rows that you've got set up. So here, if we had here, we got a number of rows that we got per bay. I'm going to put my number of rows times the 255 lineal feet of length of beams. Gives me a grand total of how much bar support I'm going to need for the bottom mat. Now let's calculate the upper mat. The upper mat is here we had a 33-foot wide bridge. So here we're going to calculate what the distance is between the rebar by taking the deck thickness minus the bottom coverage, minus the top coverage, minus the top rebar thickness and the bottom mat rebar thickness, and that remaining number will be the size of the rebar that's put in place there. Once again, you can see rebars, what type and size and how much to calculate. And that presentation actually goes more into detail than we have time for here today, unfortunately. So what you're going to do is drop your mat, all your mats in place. Here we've got 255 lineal feet. That's how long the bridge was from abutment to abutment. Divided by 4 lineal feet, because that's how you want to space rebar supports, no more than 4 foot on the center. That's going to give you 63.73 rows. I'm going to round up to 64 because you always round up to the next row, and then you always add one to start with. So therefore, you got 65 rows times 35 will give you a grand total of 2,275 lineal feet of slab bolster upper that you're going to need at a minimum. That includes no lap or anything else. So typically what you're going to look at here is if you were to have to lap on here, I'd add 5 to 10%. Since we had a 2-inch haunch, an 1.5-inch bottom cover, beam flange thickness, I would use a 4.5-inch easy chair out on the overhang, an individual chair. Primarily has a small footprint, basically supported on lumber that's typically used in fascia overhang forming. And that can actually be slid in or slid out depending. So that's never an exact science, but at 4.5 inches, based off of this, you can get pretty close to what you're looking for. And typically I run them about every 2 foot. For the whole deck, you'd need 255 pieces roughly. Finishing machine. Great product to come in here and finish off the top of the deck and everything. Problem we have is the weight of the finishing machine is also contradictory to the capacities of the overhang bracket. It basically isn't a system that actually is conducive to the overhang bracket. The overhang, because the finishing machines are getting larger and larger and stronger, so they can span wider areas, it basically is taken away from the capacity of the overhangs. So typically when we look on the wheel load here, on the bottom picture here, we're looking for that wheel load and the wheel spacing, because you have to support that load too also on the overhang bracket and the hanger. So both of those are basically included in the number for the overhang bracket. It may seem like the overhang bracket is not supporting a lot of weight. Well, it isn't really when you think about it, but at a moment when the overhang bracket is right underneath the finishing machine, it's out probably maxed right out as to what the bracket would carry. So to do all this, we actually have our bridge deck information sheet. You can actually get this online on our website, DaytonSuperior.com, print it off, send it off to your contractor, engineer. They can actually fill this out. We can run the calculations to get a calculated printout sheet for them. It would look something very similar to this, which would give you the overhang bracket spacing. There'd be adjoining pages that would actually coincide with the interior spacing, and all of this would be is basically a billable item. But typically, a lot of this can be submitted to the DOT as a pour record, because the state wants to know how you calculated all of your pouring of this bridge deck. So, and we can also provide a drawing with that, so they can all come in and get a drawing for you to accompany it, and we can put a PE stamp on it. So at Dayton Superior, we have additional resources. You can go to DaytonSuperior.com to get any of the tech data sheets, handbooks, e-marketing, product pages, even the engineering calculation sheets. You can also find your contacts, your customer service people, any of the technical engineers, and obviously training. Here you see a lot of the detail of what you can find on there. The bridge deck everything is available in PDF, so you can download it or print it. And you can actually get any of the design calculations and drawings off of that from the engineering group, as we discussed earlier, from this page. Here's it when you need an answer. Who's my sales rep? Where do I call? Go online, look up how to contact us, and find your regional map, and your regional map will actually give you the name and cell phone number of your sales rep.
That's right. Thank you, Chuck. So we're a little over time. I want all of you, if you have any questions, please go ahead right now. I'm going to stay online just for a little bit, and we can get those answered. You do it through the chat functionality or the Q&A. Or if you'd rather, send us an email at training@DaytonSuperior.com, and Chuck and I can get that back to you. A lot of good information, Chuck. I appreciate you coming to take the time to tell us. This is a good one.
Not a problem, Heidi. Like I said, feel free to use the training at DaytonSuperior.com to contact us for any additional training needs. If any of this made sense to you and you need a little more help on it, feel free to contact us, and we'll help walk you through it again.
Absolutely. And just a plug, next week we've got precast lifting systems, but then we're back at, I believe it's exterior, interior bridge deck. We're going to have those the next couple
interior next week, the week after.
Interior first. So sign up for those as they come about. And I don't see any questions, so we'll go ahead and end for today. But like I said, you have questions, or if you want something more, maybe we can put that into the next upcoming training. Give us time to do that. But, contact us at training@DaytonSuperior.com. So thank you guys for attending. Chuck, thank you for presenting as usual.
And thank you. And everybody have a great day.
Yeah, you too. Bye-bye now.